Hello, Honors Chemistry, and welcome to Chapter 5, Section 5.4, where we just we're adding branches to our table from Chapter 3, where we talked about types of matter. So if you think back to Chapter 3, right, we had matter, right, and matter could be divided into, right, pure substances and mixtures, right, where the difference there was, right, the chemical bonds, right? In a pure substance, we had in a pure substance, right, we had only one type of particle, right? One type of particle, and it could be an element or a compound, right? Element or a compound, like we see here. Whereas in a mixture, right, we had more than one type of particle, right? And those particles were not chemically bonded together, right? And so a mixture had a unique set of properties based on the ratio of the components that made it up, right? Whereas a pure substance, that substance, because it's all made of one type of particle, right, has only one set of properties, right? Thinking back to stuff that we've been talking about. All right, so then going back to our diagram here. So again, this is basically branching off of our pure substances. We have elements and then we have compounds, where compounds are made of, correct, elements that have been chemically bonded together, right? And then so further clarifying, right, we can have atomic elements, which are made up of atoms, right? And that would be the key word to describe the particles of an atomic element, right? We could also have a molecular element, which would be composed of molecules, right? Where a molecule is two or more atoms chemically bonded, yes? Or to be more specific, two or more atoms with a covalent bond, right? Thinking back to stuff you learned in middle school, right? Where the electrons are being shared between them, and that's called a covalent bond, right? So molecules are what make up molecular elements, right? Now, to further clarify our molecular elements, right? So there are a group of elements that are not present as atoms, right? So we might think that all elements are just atomic, but they're not, right? As in, like, all of our halogens, for example, right, are so reactive they are not found alone in nature, right? Along with this and those also, right? Meaning that you don't ever find hydrogen atoms. You find hydrogen, as in H2, hydrogen floating around in nature, right? Same thing with like chlorine. You don't find Cl atoms, you find Cl2 floating around in nature, right? And oxygen is one you guys should be familiar with, right? We don't write O anywhere. We always write O2 when we're referring to the oxygen that we breathe or the oxygen that's present in the air, right? So there are just a bunch of elements, right, that do not exist as atoms. They only exist as molecules, which are atoms that have been chemically bonded together. Yes? Good. And like your book says, there are this list of diatomic elements. You do need to know that list. But if you look, right, it just makes up this corner right here, right? And then hydrogen, you are welcome to mark those on your personal periodic table. Again, you may not use words, but you are welcome to color code that section or use some type of symbolism for which you don't put a key on your actual periodic table, right? So anyway, those are our diatomic elements. The ones that are beyond diatomic, right, like your book talks a little bit about sulfur and some other elements, you're not responsible for knowing those, right? If I were going to use that, I would tell that to you. All right. Then we have our compounds, right? Which are definitely made of different types of atoms. That's the difference there. But we also have molecular compounds, right? Which are also called molecules, right? Because they're made up of atoms chemically bonded together. Just in a compound, there's specifically two different types of atoms, right? In a molecular element, it would be the same atom. Yes? Right? Moleculars are same atom. Compounds are different atoms. And then we have our ionic compounds, right? Which a little bit different, right? So if we're going to differentiate here, our ionic compounds are typically going to be a metal, right, and a non-metal, because going back to descriptions of our elements, metals are things that tend to form cations, correct, and non-metals tend to form anions, right? So really, what we are saying here, right, ionic compounds are made of cations and anions, which typically will be a metal and a non-metal, right? Whereas a molecular compound is typically going to be composed of two or more nonmetals. Okay. Important note here, right? formula unit, right? When we are talking about an ionic compound, right, sodium chloride, which is what it's showing you here, right, does not exist as discrete particles of Na stuck to a Cl, right? No, that's not how it exists, right? We get these big giant crystals where there are a sodium bonded to a whole bunch of chlorines, and that chlorine, each chlorine is bonded to a whole bunch of sodiums, right? And it's this network of electrostatic attractions, yes? An ionic compound is held together by a network of electrostatic, which means oppositely charged particles, right? Electrostatic attractions. Now, what that means, right, is that there are no discrete particles. So we need a different kind of word to describe the base unit, right? And that word is formula unit. So when we're talking about atomic elements, we would use the word atoms to talk about the particles. If we're talking about a molecular element, we would use the word molecule. If we're talking about a molecular compound, again, we would use molecule. If we're talking about an ionic compound, the particle word is formula unit. Yes? All right, make sure you tie those together. So here, let's go ahead and ID the type of particle in each sample to make sure we're on the same page, right? So you'll note, right, that some of them kind of look similar, right? So you might look at this one and you might look at this one and say, ooh, those look the same, but how do you know the difference? Right. The reason the particles are all packed together are because they're describing solids, right? That's what solid means, right? Particles are stuck in place. But here we'll see that there are two types of particles, right? Where here there is only one type of particle, which means that this one has to be a, has to be a compound, but it has to be a compound that forms a network of bonds all stuck together, which means this one is an ionic compound, right? And if it's an ionic compound, the appropriate particle that makes it up is a formula unit, right? Here, if we only have one type of particle, right, this one must be a, it must be an element, right? And this must be an atomic element, right? Atomic element, which means that it's made up of atoms, right? Then we'll look at these next two for contrast, right? So here we have discrete particles that are made up of more than one atom, but again, here we only have one type of atom. Here we have three types, right? So then, if this is only made up of one type of atom, right, we know that it must be an element, right, and specifically a molecular element, which means that its particles are called molecules. Here we have three types, right, which means it must be a compound, so this is our molecular compound, which means that it's also composed of molecules. Yes? Does it make sense? All right, make sure that you can differentiate these and that you could do this on your own if asked to, because you'll probably be asked to. All right, thank you for listening. Be good and stay tuned for the next one where we start our actual naming, right? And your outline stops using the book, right? So make sure you pay attention to the headings in the outline for what you should read when and where. All right, be good. Bye.